clocked JK latch. All simple and clocked SK latch circuits examined to this point suffer from common problem of having a not allowed input combination, that is, their state becomes indeterminate when both inputs S and R are activated at the same time. His problem can be overcome by adding two feedback lines from the outputs of the inputs as shown in figure. The resulting circuit is called a SK latch. Figure shows all NAND implementation of the SK latch with active high inputs and the corresponding block diagram representation. The SK latch is commonly called a JK flip-flop. Figure: gate level schematic of the clocked NAND based JK latch circuit. Figure: all NAND implementation of the clocked JK latch circuit. The J and K inputs in the circuit correspond to the set and reset inputs of the logic of the basic SR latch. When the clock is active, the latch can be set with the input combination J equal to 1, K equal to 0, and it can be reset with the input combination J equal to 0, K equal to 1. If both inputs are equal to 0, the latch preserves its current state. If, on the other hand, both inputs are equal to 1, during the active clock phase, the latch simply switches its state due to feedback. In other words, the JK latch does not have a not allowed input combination. As in the other clock latch circuits, the JK latch will hold its current state when the clock is inactive, as CK equals 0. The operation of the clocked JK latch is summarized in the truth table. Figure shows an alternative NOR based implementation of the clock JK latch and CMOS realization of this circuit. Note that the AOI based circuit structure results in a relatively low transistor count and consequently a more impact circuit compared to all NAND realization shown in figure. While there is no allowed input combination of the JK latch, there is still a potential problem if both inputs are equal to logic 1 during the active phase of the clock pulse. The input of the circuit will oscillate toggle continuously until either the clock becomes inactive, goes to 0, or one of the input signals goes to 0. To prevent this undesirable timing problem, the clock pulse width must be made smaller than the input to output propagation delay of the JK latch circuit. This restriction dictates that the clock signal must go low before the output level has an opportunity to switch again, which prevents uncontrolled oscillation of the output. However, note that this clock restraint is difficult to implement for most practical applications. Assuming that the clock timing constraint described above is satisfied, the output of the JK latch will toggle change its state only once for each clock pulse. If both inputs are equal to logic 1 figure, a circuit which is operated exclusively in this mode is called a toggle switch. Here you can see the detailed truth table of JK latch circuit. Here you can see the figure A, gate level schematic of clock NOR based JK latch circuit. B, CMOS AOI realization of the JK latch. Thank you.